Welcome to another Python video for STA 3032. This video we're going to get into the statistics side of the house. So go to Files section of your Web Courses class, go to your and download number 8, Getting Started with Pandas. So we'll go ahead and download that. Actually, I've already got it downloaded. So we're going to open up your IPython notebook and load in the file that you just downloaded, Getting Started with Pandas. And Pandas is going to be a layer on top of NumPy that we just learned, which is on top of Python itself. So these libraries that Panda uses under the hood is using NumPy. So Pandas is all about the data science side of the house. So there's two main things in Pandas that we're going to work with. We're going to work with series and data frames. So what is a series? So let's go ahead and first thing we're going to do is go learn what a series is. We'll go to Google and we'll type in Pandas series. So if we go to the documentation and the series class inside of Pandas is a one-dimensional nd array with labels, access labels. So this is time series data or other kinds of data, but it's basically a one-dimensional array just like we learned about in NumPy, but the big difference is it's labeled. So what does that mean? So I've imported it. We hit Control Enter. You'll see that it is run. Come down here. We're going to create an array just like we did. That's a list in Python, and then we learned last class or last video that you would use numpy.array and you would put in a Python list, and that creates a NumPy array. But instead of doing a NumPy array, we're actually going to create a Pandas series. So that's what we learned before, nd array, if I can spell that right. But instead we're going to do a PD, which stands for Pandas. When we imported Pandas, we called it PD. And we're going to use their series class. And what does that look like different than a NumPy array? Well, a NumPy array just had it said nd array and then it had the values. But now we have something on this side, this column here, which is our index. And that's what Pandas mentioned, that it has access labels. So that's what these labels are. So 0, 1, 2, 3, 4 are the labels. And that's the default labels that you get, which just happens to be the index. So just like in NumPy, you can access it based on the index. So you see 0 gives you the value of 4. If we put out just the values, it looks just like a NumPy array because under the hood, that's what it is. And then if we get the indexes, it's a range index. It starts at 0, stops at 4. So just like other things in Python, it's inclusive of the first, exclusive of the last. So that's why it goes from 0 to 3, and step size of 1. So now let's learn what do I mean by index. So just like we were going to do before, this is the syntax you've seen before to create a Pandas series. We're going to create a new, we're going to do a comma, and then do index equals, and then we're going to give it our index values that we want to have. And what does that look like when you create it? Now our labels, which is our indexes, have string values A, B, C, and D. So now you can reference it just like you could before with our index, but you can also index it based on our labels that we gave it. So you can say data of A, and that's a string. That's how we created strings before. So it's single quotes, whatever value you want to have in there. So if you want to have the word test, you see that test is there now. And if I came up here and try to access A, it doesn't exist. I should get an error. But if I put the word test, you get the value at test, so you get 4. You can also get multiple values inside a series with the array syntax, so and then comma separated values. So we don't have A anymore, so I'll change that to test and B. And you'll see we get 2 values. We get test and B, which is a 1 and a -4. And just like in NumPy, this is a pointer into the data. So if you modify these, you'd be modifying the underlying data that we created up here. So when you index things, you're just using a pointer into the memory space. So be cognizant of that if you're trying to manipulate the data. But the other thing we can do is we can do Boolean expressions. We can access everything where the values are greater than 0. So here you see we have a -1, so this should exclude the column B. So let's see what happens when we run this. And you get test, C, and D. And it excluded B because this expression came back false for B. So it doesn't include that in the data. So this is how you'd subdivide it using a Boolean expression inside the square brackets. Does it act like NumPy under the hood if we multiply everything by 2? Let's see what happens. Takes a little longer, but yes, it's going to multiply the individual elements by 2 because under the hood, again, it's a NumPy array. Just now we have a special column with the indexes, and that's the value of Pandas, giving us our series. That's the big difference between Pandas series and NumPy arrays. So before, we've always had our imports all the way at the top. So the first line of code that we run is we're going to import, and that's a nomenclature that most software developers use. So everything you're going to use in this notebook, you'd want to put all at the top, so you could label it all and it'd be all organized. But there's nothing to stop you from doing it in line later in the code. So that's what we're doing here. We're going to import NumPy just as we did before, and we're going to run it through the exponential function. So that's running the data through, it's going to be e to the x of the data. So since the data is, let's reprint out data so we can see it. Lower down. Alright, what we'll do is we'll create a new cell, and then we'll go ahead and move that cell up. And I'll just go ahead and print out the data there so we can see. Oops, I'm going to control. There we go. So now we can see our data. And what does that happen when we run it through e to the x, and then x in this case is going to be 4, -1, 3, and 2. And let's go look up what e is, right? Remember in math, the mathematical constant e is Euler's number. And where is the value of it? It's like 2 point something here. Where's that at? There we go. So what we're doing here, we'll go ahead and create a new cell, is using NumPy to put everything to the exponential function. But that's no different than doing something like this, right? And you see 54.598150, taking Euler's constant and raising it to the 4. And that's our first thing, and the test value is 4. So this and this should be the same, and it is. So that's what NumPy exponential function does. Now, the other thing we can do with series data, if we remember way back in probably an earlier video, we talked about dictionaries. And so this is our dictionary syntax. We start with a curly bracket, end with a curly bracket, and then we have what's called a key, colon, and then our value. So this says London, and the value is 8.6, Paris, and the value is 2.2, Berlin, and the value of 3.6. And so when we create our series, our Panda series, we can pass in this data, city data gets passed in, and then we create our indexes based on our dictionary keys. So London, Paris, Berlin, Berlin, London, and Paris. Well, there are 2 keys that we don't have in our city data, but let's go ahead and run it and see what happens with that. So you see this first type printout here says I'm a dictionary class, and then this line here prints the data. So we'll go ahead and do that so it looks the same. You'll see Berlin gets 3.6, and that's getting it from here. And then you'll see the values that we don't have in our city data. Madrid and Rome get what's called NaN, or NaN, which stands for not a value, or not a number. That's what NaN stands for in Python. So if you see the word NaN, that means the data doesn't exist. And that's the underlying Panda series data. So you get a nice column that gives you your indexes, which you can then grab your data out of. So if you said something like, we'll create a new, data Berlin, oops, in single quotes. Oops, missed it. And you'll see you get your 3.6. But you'll notice that again it's all the way down, and then a bunch of zeros and then a 1. And this is because that rounding issue that we talked about early on in class, where floating point numbers, or numbers that have a decimal place, can't be represented exactly. So they have what's called the rounding issue, and then you'll see that way down in the weeds. So that's what this one way down here is. Now the other powerful thing that you get in Pandas is the data frame. So what is data frame? Let's look at what a data frame is. So we learned that series is a one-dimensional indie array with access labels. Let's go back and learn what a data frame is. And this data frame is a two-dimensional, which size mutable, which means you can change it, heterogeneous tabular data with labels, right? So what is this saying? It's 2 dimensions, so we're going to have look like in a spreadsheet, basically an Excel spreadsheet. We can change it so its size is mutable. Just like Excel, you could add columns and rows. It's heterogeneous, meaning it contains different type of data in a table format. And we have the same cool feature of series data where we get access labels. So now, armed with that information, let's go ahead and Control Enter this. Now, if you notice that this doesn't have the little IN and then square brackets, that's because this is categorized as markdown. If you change it to code, you'll see you get that, but this is not valid syntax, so if I try to run it, it's going to error on me. But if we just change it to markdown, you'll see we can actually run it, and that's where we get, this is what's considered a markdown cell rather than a code cell. Alright, so now let's look up what a data frame is. Here, you'll see this. Before we get to data frame, let's really define what this is. We're creating a variable called purchases. We're assigning it with the equal sign a list. That's what we start with, open and close, which means a Python list. Within that list, we're creating dictionaries. So we have a list of dictionaries. So that's the first dictionary. Then it's a comma. Then it's another dictionary. But the nice thing about these dictionaries is that they have the same keys across all of them. So all of them have a customer. All of them have an item. All of them have a quantity. Oh wait, you notice, oh yeah, this one has a quantity. This one doesn't have an item. But that's okay, because you'll see what happens is it just gets that not a number. So we have quantity, and then we have unit price. So we're creating a list of dictionary items, and that's what we're putting into our data frame. So what does that look like when you create it? Okay, this column here, this first column, that's our index column, just like we had in our series. So our Pandas series, we had that first column is our labels, our indexes. Here we have our different customers, items, quantities, and unit price. So you see customer, items, quantity, and unit price, which are our keys of our dictionary. Our keys go across the top as column headers, and then the values inside there, Bob, 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 Alice, and Alice, start going as our individual cells under the customer. And you'll see that we talked about this one here. This dictionary here did not have an item, and so you see under item we get not a number, or nan. So that's how you create a data frame from by hand typing it in. Now the reality is we'll probably never really do this, because we'll import it directly from an Excel type file, or comma separated values, a CSV file, and they'll have columns and headers, and there'll also be a table data that will pull in. But if you wanted to by hand, you could type the data in this way. Very, very rarely would you ever type in the data this way. You'd probably do an import. Data frames have an import method, and we'll go over that a little bit later. But for now, this is how you would hand type in data. It's a Python list with dictionary items, and then the dictionary keys, so customer, item, quantity, and unit price, become our column headers. Then we have our data frame, which is what DF stands for. So we created our data frame up here. We can use our location of 0. What does that give us? It gives you the first row, or the first location, which is Bob Oranges 2. That's our first one here. So Bob Oranges quantity 2, unit price 2. So that's the LOC command inside of our data frame, and then you give it the row that you want. So if I want the second row, I would use number 1. See Bob Apples 3 and 1, Bob Apples 3 1. Or you could just get all of the items. So you're going to go down the whole column by referencing the data frame item, and that gives you your. This is returned back as a Pandas series because you've gotten one item, which a data frame is a table format, so 2-dimensional, whereas a series is 1-dimensional, and that's what you get when you return back a single column within a data frame. But however, you can also remember the syntax we used last week on our NumPy was the comma separated. You give your row and then your column. So this is going to give you your single item. So your row, your first row, and under the item column, and that's oranges. So if you go back up here, you'll see first row, or row 0, under items is oranges. That's what we get here. We can also, just like before, we can do slices. So this is going from 0 to 2, inclusive of 0, exclusive of 2, so the 0 and 1. And it's going to give us 2 columns, item and quantity. Now you can't just, you have to use the location method. If you try to just grab it by the data frame, you'll see that you get an error because it doesn't, let me see if I can with you. Unhashable type slice. So you can't just natively grab inside the data frame. You have to use the dot location LOC method, basically. So you'll see, there we go. Just like with NumPy and in series data, you can also use a Boolean statement. So you're going to create a slice from data frame that's all the customers that are named Alice. And that gives you back false, 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 true, true. So the last 2 customers are their customer name is Alice, and this is how you would do things if you had a data set that was you want to split based on gender, or you want to split based on a height. You could use this this way of slicing. So you're going to get back the falses wherever you don't want the data and trues wherever you do want the data. Then you just access the slice within your data frame, and it'll give you back all of the customers that have the value true in its Boolean array. So this gives us customers 3 and 4 index, which is the 4th and 5th customer because we're 0 based, and it shows you the entire table. Now again, just like in NumPy, this slice right here is a pointer into the data. So if you change this data in any way, shape, or form, so if you added an item, so you put bananas here, it would update the original data frame because you haven't done a copy. So just keep that in mind when you're playing around with slices of data. They would modify the original. But we talked about Pandas data frames are mutable, so that means they are changeable. So we want to create a new column in our data frame. It does not exist now, so let's actually show that it doesn't exist now. We'll print out our data frame. Oops. Data frame. Alright, so if I print it out, you'll see we have customer, item, quantity, and unit price. We're adding to our data frame right here a new thing called total cost. So it's a new column, and the new column is going to consist of unit price times the quantity that they purchased. And let's see if what that does. It created a new column in our original data frame called total cost, and it populated it with quantity times unit price. Then you can, again, mutable, so we can actually remove it using the del keyword. So delete from data frame the column called total cost, and you'll see that the column went away. So we have customer, item, quantity, unit price, just like we did before. We killed, using the delete keyword, the total cost. We can also drop individual rows so to delete the columns, you're going to use the column heading. To delete rows, you use the drop keyword, and then this column here is your index. So we're going to delete 4, which would be this row there. And you'll see that it created 0, 1, 2, 3. But here you'll see that it still exists. So this dropped returns back a pointer of the data with this data missing, the customer 4, but it wasn't ever pushed back into your data frame. So your data frame still contains this row of data. So that's a little confusing, but it is a pointer, so the data still exists, and we never updated what data frame was pointing to. But when you just do a drop, your return value is a pointer into the data with the missing row. If we create, now we're doing an assignment, so we're dropping customer 3, Alice Oranges, and we're going to pass it into a new data frame. And you see that it goes 0, 1, 2, 4. That's our new data frame. But let's go ahead and print the original data frame. Oops, let's go ahead and just create a new column real quick. Push it up. And you see the original data frame is still unaltered because 3 still exists there. But our new data frame is a persistent pointer to the data missing. So if I print the new data frame, 3 is not there. Now there's this new method called inPlace, or a new attribute you can add when you drop something called inPlace, which makes it persistent and the data is now gone. So we're going to drop data index 3. We're going to print it out. Then we're going to drop index 3 with when we set inPlace equals true, and we'll print out data frame. So you'll see this is the first print, and you'll see that index 3 is still there, and that's because we did a drop without the inPlace. Then we do a drop with the inPlace, so it makes it persistent, and the second print, you'll notice that index 3 is not there. So it goes 1, 2, 4, 0, 1, 2, and then 4. Okay, last is you can access the data. Let's actually print out the data frame real quick. And move that up so we can see the data that we're looking at. So 0, 1, 2, and 4. Well, we have not a number for our item, which really is a misnomer because it's a string. All the data in here is a string, so not a number can represent anything that doesn't exist. So it doesn't have to necessarily be number. It could be a string, it could be some object of some kind. But item with NaN means is a null in other languages, but not a number in Python. So we're going to use our LOC method that we talked about earlier. We're going to go to item index 4, column item, and we're going to assign it the word bananas. So and you'll see now that Alice bought bananas. The quantity was 2 and the unit price was $3. So you can see that data frames are very mutable. You can change them all around. You can also see that you can make pointers of reduced data frames, and they're persistent, but the original data frame is unedited unless you try to do a drop with the inPlace equals true. So that's how you would make something persistent across the original data frame. Okay, that's a very short and quick video on data frames and Python series data, but this is much more applicable to our statistics, and you'll see why when we get into a couple more videos. But series and data frames are how we do everything in our statistical analysis for this class. You'll see. Hopefully in the next couple of videos it'll all come together for you.